This is a podcast on how we are going to work out the mass of products formed from a chemical equation. It sounds a bit tricky, but in fact, it's very simple. And the first thing we need to do is we need to look at an equation and make sure that it's balanced. So this podcast is first going to deal with balancing equations, and then is going to move on to how we use balanced equations to work out the products that will be formed, how much of them. So here we have a classical equation of magnesium plus oxygen goes to magnesium oxide. Now, there is something called the conservation of matter here. There cannot be more magnesiums on one side than the other, and there cannot be more oxygens on one side than the other. So we need, and using this balance here is a useful way of doing this, we need to check that both sides are balanced. And this arrow is the kind of pivot here. So in terms of magnesiums, we have one on this side here, and we have one on this side. So the magnesiums are balanced. Nice start, good. In terms of the oxygens, we have two on this side, but we only have one on this side. And therefore, we've got more oxygen on this side, which we must do something about. So we could put a 2 here. And if we do that, we can see that we've got 2 oxygens on this side and 2 oxygens on that side. So we've balanced that nicely. And now we have 2 magnesiums in the side, but only 1 magnesium on this side. So if we put a 2 here, we can see, just check it, 2 magnesiums, tick. 2 oxygens, and 2 oxygens, tick. Points to remember here which are easy to make mistakes on. First of all, you can't change the small numbers when you're balancing. You couldn't, for example, add a small 2 here. This is a group 2 metal, this is a group 6 non-metal, and the ratio of them binding to each other is 1 Mg to 1 oxygen. You cannot just add a small 2. Any balancing has to be done by adding the big numbers in front. The other thing is that if you add a big number in front, you multiply both of those by 2. It's not just 2 Mgs and 1 O. It's the equivalent of putting brackets around it. So you've got 2 Mgs and 2 Os. Okay? So let's just put that back, and we've got 2 MgOs. That could be better, couldn't it? Nice. Okay. That's MgO. I have to wait until that dries a bit. That's super slick. 2 MgO. Nice. Okay. So let's actually just look at this in a more practical way. I'd like you to imagine that these black things are magnesiums. And so in a reaction like this, the balanced equation is the way it really happens. 2 magnesium atoms react, the black squares here, react with 2 oxygens which are covalently bound to each other. Remember, they're sharing 2 electrons in their covalent bond. And they go to 2 of these, 2 magnesium oxides. So that is what the equation really looks like in terms of the atoms. We write this, and it's great, and it's easy to write the formula, but this is actually what's happening. 2 magnesium atoms are reacting with a covalently bonded O2 to form 2 lots of magnesium oxide. And when we look at this, it's important for us to use this when we want to look at how much of each of these reacts with each other. Okay, and the way we do this is to work out, using the balanced equation, which is the real way it works, to work out how much of each of these things would react with each other. So for example, you can see over here that Mg is 24 and oxygen is 16. We actually have in this equation, if we could have the ideal amounts, the truth is that 2 times 24, which equals 48 grams of magnesium, would react with 2 times 16, 32 grams of oxygen, to go to produce 2 times 24 plus 16, which equals 80 grams of magnesium oxide. So 48 grams of magnesium and 32 grams of oxygen will react to form 80 grams of magnesium oxide. Remembering that we've incorporated the big balanced equation figures. We need those. That is the truth of this reaction. Look, 2 magnesiums react with oxygen to form 2 magnesium oxides. This is the way this happens. And in fact, imagine this is happening all over the place. It's not just one reaction. If you were to think about it, the whole reaction would take place like all of those. Can you see all of those reactions taking place there? And that's just 100 millionth of the real truth. There would be billions and billions of magnesiums reacting with billions and billions of the oxygens to produce billions of billions molecules of magnesium oxide. So this is just representative of, for every 48 grams of magnesium, you have 32 grams of oxygen, which goes to 80 grams of the magnesium oxide. Now, I'd like to use the word, it's not really the right word, but this is the ideal situation, okay? If you had 48 grams, it would react with 32 grams to form 80 grams. That's perfect. But the board are not going to give you an ideal situation. They are going to ask you to work out what the products might be if you have a figure that's different from this 48. So let's say that they want you to calculate how much magnesium oxide would be produced if you actually had 24 grams of magnesium. Okay, they've given you 24 grams of magnesium. How much magnesium oxide will be produced? Well, actually, this is much more straightforward than you'd think once you've got the relative formula masses in place like this. So the first step in this situation is you balance the equation and check it's balanced. You then calculate the ideal situation where if you had the exact relative formula masses, 48 plus 32 would go to 80. And then they've given you this, and now you can work this out by using the relative ratios. So 24 is actually 24 over 48, which is 0.5. So we've only got half the amount of magnesium. And on a straight ratio, that is going to go to half the amount of magnesium oxide. And so therefore, we get 40 grams. So 24 grams of the magnesium is not the ideal situation of 48, as is dictated by the relative formula mass. It's only half that, so we get only half the product. Now, that's very straightforward. And so we can hopefully use that in order to make sure, we can use that very simple example to make sure we understand one that is harder. So if I take away that, and let's say they give us 1 gram of this. So we go through the same thing.